Hello, human geographers. Tonight we are going to be looking at the topic of where industries locate. So we're going to be talking about where they currently are and a theory regarding why they're there. So let's get started. We start out tonight by looking at the major manufacturing regions of the world. So we're talking about industry, we're talking about the secondary sector. So we start out with a definition. As always, you're underlining, but remember, underlining is not the only thing that we should be doing. How are you going to remember this? What's the key word? What are we going to associate with this? Here it is. A region in which manufacturing activities have clustered together. So clustered, concentrated, that's what we're talking about. Very close proximity. We're going to identify a later vocabulary term, agglomeration, that comes into this. So we will get there a little bit later. So the map that you're looking at here is a good example of kind of a blend of choropleth with dot distribution. It's very specifically dot distribution because those red dots are manufacturing areas. But to a certain extent, it's also choropleth because that brown shade that you see are our major manufacturing areas. And 75% of the world's manufacturing output comes from those areas that you see in brown. Which are essentially North America, Europe, and East Asia. So 75% of the world's industrial output comes from each of those areas. So let's go ahead and take a look at those areas in a little closer detail. We start out with Europe, and what I'm going to do, you have these maps in your notes, but what I want to do is discuss some of the things that are coming out of those specific areas. So what you should probably do is, draw a line from each of these different areas and kind of identify what we're seeing there. So let's get started. Coming out of the United Kingdom, we see that they are a major hub of technology, so technological production. The next area is the Rhine-Ruhr Valley, which is in Germany, Belgium, and the Netherlands. And that is the #1 industrial area of Europe. And in particular, they focus on iron and steel production. The Mid-Rhine, which is getting into Germany and France, produces a lot of steel, automobiles, chemicals, and that's the second largest industrial area of Europe. As we get into northern Italy, it's called the Po Basin. In northern Italy, they specialize in textiles. And then you get into northeast Spain, which is going to be Catalonia and especially Barcelona. They produce a lot of textiles and automobiles. And so if we were to spin this a little bit and bring in some current events, bring in the fact that Catalonia has been trying to break away and the fact that Spain does not want them to break away, well, when we take a look at the industrial output that's coming from this region, we understand why Spain probably doesn't want them to break away. This is a big economic boost for the country of Spain in that northeast part in Barcelona and the rest of Catalonia. And so if we were to tie this to some political geography, there's a very real economic reason why they don't want Catalonia to leave. Now that's Western Europe. On the Eastern European side, as we get started, we start out with Moscow. And in Moscow, they specialize in things like fabrics and different industries that are going to require very skilled labor. So typically that's going to be higher wage work, very skilled labor coming out of Moscow. St. Petersburg, that you can see there on the Baltic Sea, is specializing in shipbuilding. In Volga, which is getting a little bit further to the interior part of Russia, petroleum and natural gas. You get into the Ural Mountain region, mining, as well as iron and steel. The Kuznetsk, which is in central Russia, you can see that on the far eastern side of our screen, is going to specialize in coal, iron ore, and steel. So what we're seeing in the interior part of Russia is a lot of natural resources. We said, petroleum, natural gas, mining, iron, steel, coal. Those are all natural materials. And so that's something that Russia has been able to very effectively utilize. In the eastern part of Ukraine, we see a lot of iron and steel, so that is the area that is closer to Russia. And then in southern Poland, the Czech Republic, we see especially specializing in steel. And so just kind of knowing those general things and knowing generally where they come from. I'm not sure how this could manifest itself on the AP exam, but we need to know these areas as major industrial areas because, again, along with this region approximately is about 25% of the world's industrial output. So that's a lot. Getting into East Asia, we start out in Japan. And in Japan, we see a lot of automobiles, ships, and then electronics, cameras, stereos, televisions, things like that. And in the 1950s and 60s, as Japan was rebuilding after World War II, it was very low-wage, low-skilled work. But over time, what typically happens is that low-skilled labor becomes more skilled over time. And so what do you think is going to happen as low-skilled, low-wage labor becomes higher-skilled labor? What do you think is going to happen to those wages? They're going to go up. And so right now we see very skilled, very high-quality products coming out of Japan. Now, for those companies that were interested in low-wage, low-skill work, as those wages went up, they looked elsewhere for those labor-intensive industries that are spending a lot of money on labor. And so they moved elsewhere. But currently, the two major regions in Japan that are producing a lot in terms of industrial output are Tokyo, Yokohama, and Osaka, Kobe, Kyoto. And we're going to be talking about them pretty extensively in our next unit in Cities and Urban Land Use. And so those companies that were labor intensive and were looking to move their industries to another region with lower wages, they look to China. And so China, especially now, has seen a lot of textiles. Steel is a really big one. And really it's a variety of items that are coming out of China. And so we see those three specific regions in particular that are kind of the industrial centers of China. Notice that all of them are coastal. All right, so let's take a look. Starting in the southern part of China, Guangdong and Hong Kong are one region where we see a lot of industrial output. The Yangtze River Valley, which includes Shanghai, is another industrial region. And then on the Gulf of Bohai, we see several different areas, which include the capital Beijing, but stretching from Tianjin to Shenyang. So we see that stretch, including Beijing, where there is a lot of industrial output coming from China. And there's a reason why these areas are coastal in terms of industrial output. We're going to start explaining that today, and we're going to get into even more of that a little bit later when we start talking about export processing zones. That's going to be important. The final region that we have to look at in terms of major industrial output is North America. All right, and so we're going to look at a historical example, but also modern example as well. All right. So starting in New England, we see cotton textiles, especially during the 19th century, during the 1800s, a lot of industrial output in terms of cotton textiles. Now, we've seen that start to shift because cotton textiles are very labor intensive, so we've seen a lot of those factories move to other areas with lower wage work, in particular northern Mexico. Maquiladoras, another example of an export processing zone. And now New England has started to specialize in technology, medicine, different things like that. But that's kind of the historical example. In the Middle Atlantic, this is actually the largest U.S. market. And you can see it stretches from New York City down through Philadelphia, Washington, D.C., all the way down to Baltimore. And so in this area, we see it is the center of financial the financial industry, communication industry, as well as the entertainment industry. All right. Now, obviously, there are some exceptions to that because you think of out west, we see a lot of technology centered in Southern California, the entertainment industry in Southern California as well. So we do see some exceptions to that. The Mohawk Valley, which runs along the Hudson River and the Erie Canal, specializes in things like steel, food processing, aluminum production, paper and electrochemical production. So those are some examples. And Pittsburgh. What do you think of when you think of Pittsburgh? You think of steel, right? And so Pittsburgh was a major center of the steel industry, especially during the 1800s. And in fact, you can actually see it in the popular culture of Pittsburgh because their National Football League team are the Pittsburgh Steelers. It's not like steel spelled like I'm going to steal your wallet. It's steel spelled like the industrial product. And if you notice, every Pittsburgh team shares the same color scheme, black, yellow, and white, colors that are typically associated with steel and industrial production. And in fact, on the side of the Pittsburgh Steelers helmet, you see the symbols of sparks, representative of steel production. It's kind of interesting when you think about it, all right? But now we see that the Western Great Lakes are where a lot of the steel production is taking place now. And in addition to that, we also see automobile production, but even automobile production, like in Detroit, has shifted southward. And that's not the same industrial center of automobiles that it used to be. In Southern California, we see things like textiles, furniture, food processing, especially technology. And we see technology begin to cluster in areas where very skilled labor is coming out. And so technology is kind of centered around the California university system, with a lot of students graduating with advanced degrees, and they're able to go straight into the technology industry there in Southern California. And the last region that we can mention is actually outside of the United States, but still part of North America, and that is in Canada, in southeast Ontario, which is right across Lake Erie from our region of the Mohawk Valley. And we see very similar outputs. We see steel, we see automobiles, aluminum, paper, flour, textiles, sugar coming out of southeast Ontario. Again, I don't know that you're necessarily going to have to be able to list all the different products that come from these areas. It's possible, because anything is possible on the AP exam. But it's just good to know where some of our goods and products are coming from. And the fact that this is one of 3 major industrial centers. So now let's go ahead and take a look at a couple of different topics that relate to industrial location. So we start by talking about the difference between basic and non-basic industries. So a basic industry, by definition, is an industry critical to the health of an area's economy. And as you can see there, it says that it generates most of its revenue from outside the local area. So most of the money flowing into that area doesn't come from people living in that area. So for example, what would you say would be the basic industry for the city of Las Vegas? And hopefully you said something that relates to tourism, whether you said gambling, whether you said casinos, something that relates to tourism. Because most of the money that comes into Vegas isn't coming from people from Las Vegas. Most of the tourist money are coming from, well, tourists. And so we see a difference there. So our basic industry is tourism. Non-basic industries are industries that sell their products primarily to consumers in the community. So it generates revenue from within the community, and money is then circulated. It's kind of shuffled around between businesses within the community. All right. I get paid by the Clark County School District. I go take my money to the grocery store. I take it to the gas station. I pay my utility companies. All these different types of things are non-basic industries. I'm paying local companies for different types of services. So take a moment and try and think of another area, another city in the United States, another city in the world, and think of what is the basic industry for that city. What is the industry that generates most of the revenue from outside of the area that is critical to the health of that? It could be another US city, it could be Detroit, it could be Los Angeles, it could be New York City, it could be an international city, it could be Tokyo, it could be London, it could be Rio de Janeiro. Like, think of another city and think of, okay, what's critical to the health of that city? Then think non-basic industries. What are some of the non-basic industries that might be part of our community? I mentioned grocery stores, gas stations, utility companies, barber shops. What are some other basic industries where most of the money is circulated within the community? They generate most of their money from within the community. Now, it's important to understand this concept called the multiplier effect. Put a star next to this, because I would be willing to bet that the multiplier effect is something that you might see on the AP exam. All right, I think it's an interesting topic. And the multiplier effect says that for every one worker in a basic industry, there are 2 to 3 workers in non-basic industries. So for example, if the tourism industry, if we open a new hotel down on the Strip, and they're going to hire 1,000 workers to work in that casino, well, then we would need 2,000 to 3,000 more workers in non-basic industries. Reason being is that those workers from the casino, if they're coming in from outside of the community, and we know that we have a large migration into southern Nevada, those workers, they're going to need to shop at stores. They're going to need to go to gas stations. They're going to need houses. They're going to need barbers. They're going to need all these different types of things. And so you can't have that for that one casino worker. You can't have the same person bagging groceries as running the gas station, as cuts their hair. So you have to hire more people. Otherwise, the lines just get longer. And so for industries within that, hey, they're going to have to either open a new store and hire more people. They're going to have to hire more people to take on the additional customers that they have at their store. That's what the multiplier effect is. That for every one worker in a basic industry, there's 2 to 3 workers in non-basic industries. So job growth is driven by basic industries. This is important. Job growth is driven by basic industries. However, most of the jobs are in non-basic industries. Can you understand the difference between those? Job growth is driven by basic industries. Because if you increase 1,000 jobs in a basic industry, that's then going to create 2,000 to 3,000 jobs in non-basic industries as well. But most of the jobs are going to be in non-basic industries, because for every 1,000 jobs in a basic industry, you're going to get 2,000 to 3,000 more jobs in non-basic industry. So that's a very subtle difference that we have to be aware of. Now, when it comes to where technology and industry locates, there's this quote that comes from Adrian Bailey, who is a professor at the University of Leeds in England, and they said, "The combination of energy sources and technology greatly impacts the times and place of industrialization." So essentially, technology plus energy gives us the opportunity for industrialization. So as countries reach that crossroads of technology, where they have the technology, and enough energy to support that technology, then they are able to industrialize. So for example, the Industrial Revolution began in rural areas because they had access to specific energy resources. For example, the piece of technology called the water frame, invented by Richard Arkwright, utilized water power to power the machines in early factories. So in order to do that, you had to be next to a stream, and what we noticed is that those streams didn't run through cities generally. They were more abundant in rural areas. However, as new technologies emerged, like the steam engine was powered by coal that heated the water, that produced steam, that powered these machines. Now that freed these factories up from being directly next to a river. And so those factories, where most of this mass production took place, were able to move to urban areas where most of the workers were. So there's several different factors that that play an impact on industrialization. All right. Obviously, we just mentioned the crossroads of technology and energy. But the next thing that we have to mention is our site factors. Okay, these are location factors related to the costs of factors of production inside the plant, such as, and these are important, land, labor, and capital. If you are a business owner seeking to open a new factory, there are certain things that you're going to have to think about. You're going to have to think about how much does the land cost where I'm going to build my factory? How much are the labor costs? How much are workers going to want to be paid? And then how much is it going to cost to build the building? How much is it going to cost to get my raw materials? How much is it going to cost to get the machines to operate in this factory? Those are your land, labor, and capital. All right? And so essentially what productivity is the value of a particular product compared to the amount of labor needed to make it. So as a factory owner, you have to weigh your site factors, your land, labor, and capital, versus how much are you going to get for your product. So you have to weigh those and make sure that you're not spending too much on land, labor, and capital and getting too little for your product. And that then brings into the topic of conversation, situational factors. So site factors are inside the plant. Situation factors are location factors related to the transportation of materials to and from the factory. It's situation relative to other places. Where are you getting your raw materials from? Where is your market? How much does it cost to ship from one place to another? And then obviously, one thing that as a factory owner you would have to consider is the physical geography, because not all businesses can be everywhere. A great example of that is agriculture. Agriculture can't be everywhere. As much as we in Nevada would like to grow intensive wet rice, it's just not going to happen given the climate that we have here. And so things would have to dramatically change. So you would have to weigh all these different types of things in deciding where to locate your factory, where to locate your industry. Which now brings us to some of these theories of industrial location. So these are several definitions, and these are going to be important. So here's our definition. Location theory, a logical attempt to explain the locational pattern of an economic activity and the manner in which its producing areas are interrelated. The agricultural location theory contained in the von Thunen model is a leading example. So, location theory applies to any type of theory that attempts to locate where a particular economic activity works. In the primary sector, that was von Thunen. But right now we're talking about the secondary sector, manufacturing, industry. So in this case, the location theory for industry, the industrial location theory, is what we call the least cost theory. And the least cost theory was a model developed by Alfred Weber, according to which the location of manufacturing establishments is determined by the minimization of three critical expenses: the cost of labor, the cost of transportation, and the concept of agglomeration. Now, first off, what is agglomeration? Agglomeration, another one of our vocabulary terms, we mentioned it earlier tonight, is a process of the clustering or concentrating of people or activities. The term often refers to manufacturing plants and businesses that benefit from close proximity because they share skilled labor pools and technological and financial amenities. We mentioned that technology industries cluster in Southern California because of the very strong university system there. We also see it in other areas like in the Northeast. In New England, we mentioned there's also a lot of technological production because of the very strong university system there. In Boston, Harvard, MIT, all of those are great examples of universities that produce a very skilled labor pool, and therefore industries are going to locate close to that, in close proximity to one another, which we call agglomeration. So essentially what Alfred Weber did, Alfred Weber was a German economist, geographer, sociologist, and theoretician of culture. And essentially what he did is said that for a secondary sector activity, you have to think of three things. You have to keep your labor costs down, your transportation costs down, and you have to consider the benefits of agglomeration. All right, you have to take a look at that. So let's take a look at how this theory works. The least cost theory weighs the cost of transportation and labor and the advantages of agglomeration. That's essentially what that definition is. So if we were to shorten it down, make it a little bit more usable, that's essentially what we're talking about. So we're going to mainly focus on transportation. Obviously, labor is an important part and the benefits of agglomeration are important, but in this case, we're going to mainly talk about transportation. So for a factory owner, you have to take into account the cost of shipping your raw materials and the cost of shipping your finished product. Essentially, transportation costs are higher when the item is heavy. So those transportation costs are based on weight. And we have two vocabulary terms that go along with this. The first is a bulk gaining industry, an industry in which the final product weighs more or comprises a greater volume than the inputs. So if the finished product is going to weigh more, that industry is going to locate closer to market because they want to minimize the distance that they have to transport the heavier product, in this case the finished product. Therefore, they're going to locate closer to market. They're willing to ship those raw materials further because they are lighter and cost less to ship. On the flip side of that, we have bulk reducing industries, an industry in which the final product weighs less or comprises a lower volume than the inputs. And so for a bulk reducing industry, they're going to locate close to the raw materials to minimize the distance that the heavy items are shipped. In this case, those are the raw materials because the finished product weighs less or comprises a lower volume than the inputs. So let's go ahead and have one of our fun little quizzes. Let's have a fizz and take a look at several different industries and decide whether they are, first off, bulk gaining or bulk reducing, and then more importantly, are they going to locate closer to market or are they going to locate closer to the raw materials? So we start off by taking a look at automobile manufacturing. Automobile manufacturing, first off, is this a bulk gaining or bulk reducing industry? Answer that question, because once you answer that, then you're able to answer, therefore, is it closer to market or closer to the raw materials? Bring these answers to class because we're going to review them. Lumber, a lumber company taking raw materials like trees, converting them into other products. Is that bulk gaining or bulk reducing? And then closer to market or closer to the raw materials. Soda bottling. A soda bottling plant, is that going to be bulk gaining or bulk reducing? And is it closer to market or closer to the raw materials? Next one, ethanol plants. Ethanol is a form of fuel that uses corn. Is this going to be bulk gaining or bulk reducing? And is it going to locate closer to market or closer to the raw materials? If you need a hint, take a look at the image that you see there. Do you see the market or do you see the raw materials? Next one, in this case we're looking at copper smelting, but really anything that does metal smelting, like, well, don't want to give that one away. Like heating up the raw material of an iron or copper or steel, like whatever it is that going to be bulk gaining or bulk reducing? And then is it going to be closer to market or closer to raw materials? And finally, a potato chip manufacturing plant. All right, are we going to see it as bulk gaining or bulk reducing? And is it closer to market or closer to the raw materials? Bring those answers to class because we're going to discuss them. We got a couple more things that we have to get to tonight and then we will be all finished. Other things that you have to consider when it comes to transportation. Obviously, we just know that heavier items are going to cost more to transport. But there's other questions that need to be addressed. Like, what modes of transportation are available? What kind of infrastructure do you have? We've talked about infrastructure throughout the year, but what is it? So infrastructure is the stock of basic facilities and capital equipment needed for the functioning of a country or area. So modes of transportation are part of infrastructure, but also utilities are part of infrastructure. There's a lot of different things that fit under the definition of infrastructure. And that applies to transportation, at least in this case. All right. When an industry must use multiple forms of transportation, what they will typically do is locate near a break of bulk point. And a break of bulk point is a location where transfer is possible from one mode of transportation to another. And on the next slide, we're going to show you an example of a break of bulk point. And then finally, what happens if you don't need to worry about transportation? What if you're not transporting something? What if what you're doing doesn't cost anything to transport? Well, a great example of that is a footloose industry, okay, which is a general term for an industry that can be placed and located at any location without effect from facts such as resources or transport. A great example of a footloose industry is a call center. All right, you're having problems with your computer, you call in, and you need to talk to somebody. So you need technical support. All right, that can locate anywhere because all you need are people, and then you need the computers and the phones and that kind of stuff to do all that. But you're not shipping in raw materials, you're not shipping out a finished product. So really, it can locate anywhere. So if situational costs don't really matter, then you're really going to care more about your site costs, like land, labor, and capital, and especially labor. So what we've started to see is a lot of footloose industries, like call centers, are going to be very, very contingent on even just minor increases in site costs. Like if a country raises the minimum wage, or if we see an increase in land values and thus an increase in their rent. And so we've seen from a lot of footloose industries outsourcing. And outsourcing is a decision by a corporation to turn over much of the responsibility for production to a third party. So we've seen a lot of, for example, call centers outsourced to other countries where, for example, in the southern parts of India, we've seen high levels of education, high levels of English fluency, and so a lot and much lower labor costs. And so a lot of call centers have outsourced to other countries that have lower labor costs. And you make that connection, you call that call center, and they help you out from somewhere around the world because it is a footloose industry. And those footloose industries are very much tied to site costs rather than situational costs. So we mentioned on the last slide that this is an example of a break of bulk point. All right, and what you see here is this term called containerization. And we've seen the rapid growth in containerization, these giant metal shipping containers that are a universal size and can be loaded on the back of flatbed trucks. They can be loaded onto semi-trucks and very easily transported to these massive cargo ships. And so this is something that has allowed and facilitated the ease of transport. But you can see here a break of bulk point. They're taking the containers off of the truck and they're preparing them to load onto a ship. And this is a perfect example of a break of bulk point. And so industries that have to use multiple modes of transportation are going to locate here. All right, so that they can ship their goods out by truck, or they can ship them out by sea. All right, typically, or maybe by plane if there's a nearby airport. So it really kind of depends on what product you're talking about. But if they use multiple modes of transportation, an industry is going to locate near those modes of transportation. Finally, last bit tonight is talking about how Alfred Weber came up with this industrial location theory. And there is a practical tool called the Varejão frame, named after Pierre Varejão, who was a French mathematician. And the Varejão frame was a system of weights and pulleys that is used by geographers to help determine the optimum location for something. For example, the weights might represent the relative cost of transporting a particular good to or from a particular location to help a firm decide the most cost-effective site to locate a prospective production facility. So, the way that we're going to use the Varejão frame is by using the locational triangle. And the locational triangle, you see it in the bottom right there, weighs or balances the cost between a market, which you see at the very bottom, and two raw materials. All right. And what you see, so start with raw material 1 in the upper left-hand corner. Those semicircles that radiate out from there are 5 of them, set at equal intervals, and they are called isotems. And each of those represent equidistant areas away from that raw material. Hey, it could be 1 meter, it could be 1 mile. All right. In this case, it's looking at miles. So you see the first isotem is 1 mile, and then 2 miles, 3 miles, 4 miles, 5 miles. And you notice that each of these raw materials and the market have 5 isotems radiating out from that. Our job is to try and balance those, find the ideal location for the cost of transporting the first raw material, the second raw material, and finally how much it costs to ship that the finished product to market. And we're going to do that in class tomorrow. So have a wonderful night, everyone, and I'll see you in class.